I was about to start repair on this power supply from an HP 9845B. This is not mine, this belongs to somebody else, and it's been sitting here now for well over a year waiting for repair. So sorry about that, Dave. I will be getting onto this shortly. But before starting this, I just wanted to respond to a comment. It was quite a good comment, and it prompted me to think about maybe just clarifying something with regard to the repairs I carry out. Now, when I post a video, what you see is really the tip of an iceberg. So for example, when you see the repair videos for this, I only really show the things that are likely to be of interest to people. I don't show all the donkey work and the tedious testing I do behind the scenes. So you only see about 5% of the work involved in carrying out the typical repair. Now, part of that is running the units that I've repaired for a length of time. And that will normally require the use of at least one power supply. So you recognise this. I've made quite a few of these, and you've seen a few videos about these in the past. And this is really why I built these. I needed some power supplies. I do have my bench supplies, of course, but I want to keep those available for doing the actual repairs, testing and other things. And so as a minimum, what I normally need is a power supply, usually a fairly capable one. It doesn't need to be that precise, but it does need to be able to supply usually fairly high voltages. So if I'm testing a switch mode supply, for example, I might want to run it on DC with the current limit, and often I need quite a lot of power. So something like the Rydon's quite useful because it can supply up to 600 watts. So 10 amps at 60 volts is quite a good supply. And I have made a couple of linear versions of this as well for more detailed testing. But also when I'm testing things, I also need at least one multimeter. So the equipment being tied up for testing that might sometimes run for several weeks can get quite extensive. So I might need 2 multimeters, maybe 2 or 3 supplies, and that can be sitting running for a long time. So the comment in question I mentioned a few minutes ago was for or about the HP tape drives that I've repaired. I did a huge amount of testing on those when I first started repairing them. I've repaired over 100 of them now, but when I first started, I'd done about 20 and decided I wanted a bit more information. And like I said, I like to learn about the things I'm repairing when I have an opportunity, and having access to a piece of equipment gives me that opportunity to learn much more about them. But the sort of testing I do is very detailed, largely so I can learn as much as possible about them, but also to make sure the repair goes the way I want it to. But tying up all the equipment means I end up with lots and lots of pieces of equipment. Some of it's fairly expensive, and I don't want to keep stockpiling and stockpiling equipment just to do soak testing. So what I wanted was some way to kind of combine this into a much more manageable form and a much more cost-effective form. Let's get this out of the way. So what I saw recently, in fact I saw them a while ago now, but recently I decided to bite the bullet and try one of these. So I will get this out of the box and show you what it is, and we'll see if it's actually any good for what I intend to use it for. Okay, so this is an Owon Spm6103. It's a combined switching power supply and digital multimeter, and as you can see, it's quite small. It's smaller than the multimeter I just showed. It's about the same size, not quite as long, but about the same size otherwise as the Rydon power supply. It's very light, weighs probably less than a kilo, but it is a 300 watt supply, at least in theory. I haven't switched this on yet, haven't tested it. I don't know how good these are, but first signs are promising. It looks like it's fairly well made. All the bits fit together very nicely, no sharp edges. This was, I think, £140 delivered, and this is, as I say, the SPM6103. So this is a 60 volt 300 watt unit, and it can supply up to 10 amps, but of course not at 60 volts. It will do 5 amps at 60 volts, or 10 amps up to 30 volts. So it's quite capable, but quite compact. Looks like it's got quite a nice interface. Don't particularly like black panels on equipment. Seems to be a trend at the moment, but I don't really like it. But like I said, I bought this because it combines the supply and the multimeter that I frequently need to use when I'm doing long-term testing. So if this works, I'll buy a few more, then I can use these instead of tying up the expensive equipment that I don't really need to. But as I say, on first glance, it looks quite nice. Controllable through USB, I believe, and you can capture data through the USB. So you can do data capture with this, and we'll have a look. I won't show the software, and this is not a full review, by the way. This is just a quick glance, and we'll power it up. We will have a look inside, and it's just really to get some idea as to whether this is likely to be suitable for what I want. But because it will capture data, one of the reasons I quite often use, let's grab this again, one of the reasons I quite often use the Agilent 34461A, which is what this is because it has a trend graph. It will show you the history of current voltage or whatever you want to monitor, and that is very useful if you're doing long-term testing. If something fails, generally by the time it's failed, it's too late to see what happened. You've got to try and figure out what went wrong. But if you're capturing data as it's running and then it fails, quite often the data will show you what the issue was. So with something like this that will capture data, it's quite useful. It means that I can leave something running, capture the data, and then if anything does go wrong, I can see what happened. It says 5 amp fuse, but I can't see. Okay, so the fuse is on the bottom. Like I said, it's nice and small, it's compact, seems to be nicely made. So the next step is we'll power it up, see what it does. So it comes with a power cable, USB cable, and some test leads. Like I said, it is a multimeter as well. Not the best test leads I've ever seen, but actually quite reasonable. It's kind of quite a nice flexible wire. It's not the usual PVC stuff that you get, so they're not too bad. I won't be using those today, but they will come in handy. So let's switch this on and we'll see what it does. It's a mechanical power switch at the back there. Quite a nice looking display. It's not especially bright, but it's quite clear. And I haven't read the manual for this, so we'll just fumble our way through. I'll look at the manual later, but like I said, I just want to get some sort of feel for how well this works and if it's going to be suitable for what I intend to use it for. So press the display, and it looks like we go through to the various modes, including the multimeter. So it's got a range. Okay, got a clickable knob there, that's quite nice. Memories, lists, so this again quite nice. It's got some quite nice features already by the look of it. Auto holds, so I presume if you touch the probes onto something, it will do an auto capture. And trends graph, so that's one of the features that I really like and one of the reasons I bought this. Okay, well, it's looking promising so far. The interface is quite clear. Okay, so we've got a dedicated button to set the voltage. So currently it's set to 50 volts, so we can vary that. It's quite nice. I presume we can do the same with the current, which we can. So it's a 1 amp for now. And then we've got the limits here as well. So again, dedicated button for each one. Voltage limit set to 62 volts. Current limit set to 10.2 amps. As I said, it will only do 10 amps up to 30 volts. Beyond that, the current limitation starts to drop to limit the power to 300 watts. But it looks quite good. We've got the soft keys along the top, usual connections for the multimeter, and we've also got a USB 5 volt 1 amp port down here, which is obviously to supply power to USB devices. So again, quite nice. What I'll do now is I'll get electronic load and a multimeter set up, and we'll put this through some basic tests. So I'm not going to do a full review, and we'll just see if it does what it's supposed to. Okay, well, apologies as ever for the flickering on the Kunkin electronic load. So I've got this set up so we have the Agilent 34461A set so that it's connected across the multimeter connections on the Owon, and this multimeter is calibrated, by the way, so this is accurate to a few microvolts, so whatever this is saying is what we really need to be going off for the actual voltages that we're seeing. I'm using remote sensing on the Kunkin so that this will be as accurate as possible. Like I said, I'm not that concerned with absolute accuracy, but it will be interesting to see how good this is. The specification for this is it's not fantastic for a multimeter. It's 4.5 digit, which is quite good, but it's not a top-end multimeter. It's mediocre at best, but as I say, that's all I need for the types of testing I'll be using this for. It's just to do monitoring of ongoing tests. It's really the combination of the supply and the multimeter I'm interested in, so it saves me tying up anything that I want to use elsewhere. So for example, I can use this to do what I was doing with a ride and one of these. If I have two of these, of course, it saves me double. Okay, so we'll set the voltage. It's on 10 volts, I'll leave it at that. It's set to 1 amp, so I'll leave it at that. And we'll switch this on. We've got the Kunkin set to 5 amps. We'll switch this on. And straight away we can see that the error is very small. It's very precise. It's very close to the correct voltage at 10 volts. We'll try turning the load on. Now, one of the issues when you have a system set up like this for testing is these electronic loads they don't have a proper ramp up test. You can modify it, but it's again, it tends to misbehave if you don't use it in the right way, and it looks like the power supply is faulty when it's not. What we need to do is set this so it's got the same current limits as we have on the supply, otherwise they'll kind of fight each other. Okay, so what we have now is it's showing 9.982 on the SPM and 9.992, so it's within a few millivolts of being correct. The current looks precise enough. This Kunkin is calibrated as well, so the current is quite accurate on this, and we'll off camera test the current and see how precise this is. If you want to see more of the testing of this, let me know. I'm as I say, only doing a very brief run-up of this and seeing if it behaves itself. So what we'll do now is we'll increase the voltage. I'm going to leave it switched on while I do this, so we'll go up to 20 volts. Again, very close to being the correct voltage. Okay, we'll go up to 30. Bear in mind that we're under the 5 amp limit, so we can go all the way up to 60 volts on this. So we'll change this up to 30 volts, 40, 50 and 60. And still you can see this is quite precise. Like I said, it's not you know, instrumentation type quality or precision, but certainly good enough for a supply that I intend to use for soak tests. So we'll turn the voltage back down and we'll start increasing the current and see what happens there. Okay, now I'm going to use the Kunkin in constant current mode, because otherwise I'll have to keep changing the dynamic response. Otherwise they'll fight each other. So we'll change the current. So press the current. That works. I'm going to go up to 5 amps, and we'll do the same on here. Turn that back on. 5 amps, and I'm assuming something on here. We've got power shown in the middle here. It's in constant voltage mode, and it's even got a timer showing how long it's been powered up for. So it's showing 49.5 0.7 watts. So this is showing 49.81 watts. So again, very close, and as I said, this is calibrated. So we'll go up to 10 amps. I'll leave everything switched on, we'll just increase the current, see what happens. I need to turn it off. Okay, 10 amps, so this is showing us at 99.4 watts. Again, very close to what the Conkin is showing. And you can see that the voltage is very close, 9.93 on the Owon, 9.939 on the Agilent. And what we'll do now, if I try and increase the voltage up to 30 volts, I've got to 29 just to make sure we don't go too far, we should be able to still run it at 10 amps. So increase this to 29 volts. Okay, so 289 watts. We'll try 30, see what it does, but it might kick in the power limit if we go any higher. Oh, it is actually working fine. So it's showing 299.1 watts output. Voltage is 29.88 according to the supply, 29.93 according to the Agilent. So the Agilent is saying the supply is better than it thinks it is. We'll try changing the display and see if the multimeter display is separate from the power supply display. I kind of assume they're both the same. Which they are. And there we have a trend graph. Now, as I said, this is one of the reasons I wanted this. It allows me to keep an eye on things while the test is ongoing. I don't have to try and guess what happened later on. If we try reducing the current, then that should show. This shows voltage and current, by the way, at the same time. So we can see that is indeed doing what we would expect. Okay, so I'm going to bring the current down and we'll try ramping up the voltage. So it's beeping because I've gone down to 0 amps. We'll put 2 amps on there. It's complaining, of course, because this is set to 10 amps, but we'll reduce this. That's looking fine. So now we can increase the voltage. I'll go all the way up to 60 watts. So again, we'll go up to the power limit. It's currently at 120 watts. So we'll start increasing the current. Now in theory, we should be able to go up to 5 amps. Change this to 5 and working fine. So 299.56 watts. Go back to our main display. We can see that's fine. 4.996 amps. We're showing 59.87 volts on the supply, 59.95 volts on the Agilent. So far I'm actually quite impressed. It's doing what I would expect. You can hear the fan in the Conkin starting up. I haven't heard a fan in the power supply yet, whether it's just very quiet. I know there's a fan in there, I could see it through the rear grille, but it's not running yet, so that's looking quite promising. It's supposed to be, I think, 88% efficient. So it's looking good. If you want to see more of a review of this, then leave a comment. But what I'll do now is power all this down. We'll take the cover off and we'll have a look inside and see what's in there. It's probably just a very basic switching supply and multimeter. Whether on the same board or not will be interesting to see. Okay, that's all the screws out, so let's have a look inside and see what we get for our money. So obviously we've got the back of the board. Let's spin this around and have a look inside. Okay, well, first signs, it looks very good. It's the quality is a lot higher than I would have expected. They could have made a better job at soldering the board onto the mains socket. This is all loose, so it looks like it just slots together once the main case screws are out, so it'll be quite easy to repair if ever we need to. The main board looks quite good. Everything is held in place. It's all secured. As I say, there's a fan in here, but I don't think it actually ran. Okay, let's quite surprised. Let's try and look at the multimeter part of it. It looks like that's all integrated into the main control on the front board, so it's quite a surprise. I was expecting to see a separate card for the multimeter, but it looks like they built a controller and multimeter board that drives everything. Looks like there's quite a decent processor on there. So okay, well, that's all there is to see in there. We've got a temperature sensor on the heatsink, nothing on the other one apart from the power devices. Top of the board is supported on a bracket, so that's quite good. We've got a plastic standoff at this end. It will wobble about, I assume, in transit, so could be better there, but not too bad. It's quite a big board, so it'll be fairly stiff, although there are some fairly heavy components on there. This cable's a little bit tighter than would be ideal, but obviously once it's all screwed together it should be fine. So yeah, overall I'm quite impressed. It's not an expensive device. It's not, you could get a supply and cheap multimeter cheaper, but I think for the convenience of having these two combined, and what is actually quite a capable supply, I think it's quite reasonable, and yeah, looks quite good. I'll get this reassembled and then we'll finish off the video. Okay, so first impressions are good. I'm fairly sure it will do what I want it to do and meet the task I purchased it for. It will allow me to soak test equipment, capture data and carry out tests while that soak is underway without having to tie up other supplies or multimeters. The only thing I'd change if I could is I don't like the black panel on the front. I think it makes it look cheap and tacky. I'd much prefer the bone colour that you get on the bigger Owon supplies. But other than that, I think it looks quite nice. It's certainly very nice and small, and it's quite nice and light. It is a switching supply, so obviously we need to bear that in mind if we're carrying out certain types of testing. I will be doing some in-depth testing on this to check for ripple, impulse energy, that sort of thing, step response, accuracy under different loads, and also testing the accuracy of the multimeter. I'll check the accuracy of the current, make sure it's stable, make sure it doesn't overheat, so I'll run it for maybe 24 hours at full load and see how it goes. But certainly first impressions are good. As I said, if you want to see more testing on this, then leave a comment.